Assalamualaikum and a very good day. So this is inverter topic. So the definition of the inverter, as can be seen from this slide, it converts DC power into an AC power by switching the DC input voltage or current in a predetermined sequence so as to generate AC voltage or current output. Okay, and the typical application of this inverter can be found in uninterruptible power supply application or UPS, adjustable speed AC motor drive, which is your induction motor, high voltage DC transmission, and also solar panel, for photovoltaic system, and mostly on the renewable energy edge. And this is the general block diagram of the inverter. As you can see, we have DC power, okay, and the symbol of the DC, and then the output is an actually AC power. Okay, and there are several types of inverter. Okay, so we have the first one is what we call the voltage source inverter. Okay, and then we have the second one, which is a current source inverter. Actually, we have also the third one, what we call the Z source inverter. So Z is actually impedance. Okay, impedance source inverter. But most of there are several advantages of these inverters, but the most common use is actually the voltage source inverter. So as you can see, we have a DC voltage input, and we have a capacitor connected parallel with the DC input, and sometimes or usually this capacitor also we refer as a DC link. So what is the purpose of DC link here is actually to make sure that the input of the inverter is purely DC voltage, because as you may recall, the function of this capacitor is actually to smooth out the ripple, okay, to move out all the harmonics inside the voltage DC. Okay, so so in this topic, inverter, there are tools actually main what you call main components that we need to go through first. So the first one is actually the topology of the inverter, and since this inverter use a switching, so use a switch to convert DC to AC, so there are several methods, okay, or switching strategy that can be used to control all the switch. So we go first for the topology. So the topology that there are several types of topology or circuit. So in this class, so we are more concentrating on what we call the full bridge inverter. Okay, so the full bridge inverter is, I draw it for you. So this is your VDC, your DC source. Okay, and then you need to have a link, okay, and switch. So this is your switch, okay. And for your information, so this is what we call link. This is also link. So meaning that for the full bridge, we have two link. Okay, so sometimes we call two-leg inverter, and for each leg we have two switches. Okay, for example, so two switches. So this one is S1, S2, S3, and also S4. Okay, and switch S1 and S3 must not, this is the rule, must not turn on at the same time. Okay, meaning that also S4, S2, and S4 also. So we avoid these both switches switch at same time, because when we switch, for example, if S1 and S3 are switched on together at the same time, it will make the circuit to be short circuit. Okay, so that is why we avoid having both switch in the same leg to actually switch them on. So this is your V out, positive, negative. So this is actually the full bridge inverter. And for the switchings that we will actually go through, so most of the topic will be discussed based on this inverter topology. And for the switching strategy, to control this timing, the switch on and off of these four switches, so we go for the square wave. Second one is the quasi square wave. The third one is the bipolar PWM. Okay, so there are three switches, three switching strategy that we will go through, and based on these three, this is the simplest and this is the advanced and more flexible. More flexible compared to the other square wave and quasi square wave. So we will move on the next lesson, which is the square wave inverter.